Hi, we're the Bellisamp R-Balloon Mold Design, Concrete Mix, and Manufacturing Design Project Team, a multidisciplinary senior design team in the Kate Gleason College of Engineering. We're working alongside the HOPE group to optimize a previously developed alternative to the typical toilet to combat rising sanitation concerns in the Haiti region. The R-Balloon is a cost-effective alternative that can be purchased to provide bathrooms to those who normally wouldn't be able to afford one. Our objective was to improve the previous design by optimizing the concrete mixture, redesigning the molds, and simplifying the manufacturing process.
The team began this project by optimizing the concrete mix. In order to make a lightweight concrete, biochar and char dust were used. This material is carbon-rich, organic matter that has been burned at a high temperature. The hope was that this material would fill voids in the concrete and replace the heavier aggregates. This material did lower the weight of our samples. However, there was a significant drop-off in strength.
Before we started to manufacture a full-size mold, we wanted to test our design on a smaller scale. To do this, we filled a two-sided 3D printed mold to see if the mold could be filled properly without any air bubbles. The second small-scale mold was used to test if we were able to successfully remove the concrete from the MDF mold. We were not able to remove the concrete from this mold, but we think it is mainly due to the dimensions of the scaled-down mold being too small.
Medium density fiberboard was chosen to form the geometry of the mold because it is cheap and easy to work with. The next step of the prototype was to find the best combination of a sealant and release agent to use with the MDF. After molding many concrete test pucks, we were able to determine that a water-based polyurethane paired with a off-the-shelf vegetable oil would give us the best mold release. The group decided that gluing the MDF layers and bolting them together would be the most effective and consistent way to fuse the mold together. After breaking down the process to make an R-Balloon, we mocked up potential manufacturing layouts. This layout places the workers between the raw materials and the finished product, reducing the amount of movement in the process. The production process will be rate limited by the number of molds present. With a cure time of 24 hours, the number of molds provided to the workers must be equal or greater to the desired throughput per day.
So this is our mold for our R-Balloon. This is one of our molds. This is a combination mold. You have a one-sided mold accompanied with a plunger-style mold design that we created. For the plunger-style mold design, we have these mold releases that will connect in series on the bottom, creating the bottom geometry of our dome shape here. And then we also have the same thing accompanied for our beam on the one-sided mold. Then for the dome, to form the geometry, you have our plunger-style covers that go on top, and that will seal the concrete and create the geometry we're looking for. And this is our mold.